Hey guys, welcome to Task List A. We are going to be discussing A-01 through A-14. Alright, first up we have A-01, measure frequency, aka count. So you're measuring frequency, which is a direct measure. It means to count whatever you are measuring. So you could be counting the number of times somebody says like in a sentence, or you're counting the number of times somebody hits the desk. You could also count how many words are spoken. You're going to ask yourself, how many instances, the keyword instances, occurred? Or how many times, the keyword times, did that happen? So frequency, as easy as it said, is count. The AKA is count. You're counting. It is part of continuous measurement, which we will get to, but I wanted to pair it together now so that you hear it repeatedly over time and you're able to match the two together. Frequency, also known as count, is the most widely used measure in applied behavior analysis. Okay? It's also part of reliability. So we're going to count instances of behavior, or we're going to count how many times something occurred. You could use frequency in your everyday life. I'm sure you do all the time. It's a part of the measurable dimensions. It's part of continuous measurement. It's just a simple tally of the number of occurrences of a behavior. So another example would be the number of correct and incorrect answers written on a practice sheet. Think about teachers when they're grading worksheets or they're grading spelling tests. They're using frequency, they're using count. And then later on, we can utilize the count into a percentage. A-02, measure rate, which is also count per unit of time. This again is another continuous measurement system. It's also part of the measurable dimension of reliability. Rate is the ratio of count per observation time. So often expressed as per minute, per session, per hour. It's a direct measure. We could also say per year. We have one birthday per year. This is really just frequency with the addition of a time period that you're using. So you're going to want a certain number over a certain duration. Now that duration is not how long the behavior occurred for. That duration is how long you are sitting there watching, how long you are observing for. So if you went in and you recorded a 30-minute observation period, and during that 30-minute observation period, that child threw his pencil 16 times, you're going to say within 16 times in a 30-minute period, that student threw his pencil. So 16 over 30. Okay? So we could say the formula for rate basically is just adding up the behaviors, and that's over time. It's usually reported as per second, minute, per day, per week, per month, per year. It's used for recording free operant behaviors, which are behaviors that are discrete. They have clear beginnings and clear ending points, so you know when they're occurring. It's used for low rate behaviors, not high rate behaviors. It can be emitted over a wide range of response rates and at any time. And it's considered part of continuous measurement, which is a discontinuous behavior. It eventually stops. Then we have A-3. This is measure duration. Now this is part of temporal extent, whereas every instance of behavior occurs during some amount of time. It's also part of continuous measurement. Though it's part of continuous measurement and it's considered a discontinuous behavior, it is good to use it for high rates of behavior. So, in essence, duration is the total extent of time that a behavior occurs. This again is a direct continuous measurement. It's measurement of temporal extent. For example, total time of each tantrum, time it takes to chew each bite, or time spent scrubbing hands when washing. We are recording behaviors of how long these behaviors occur for. Then we also think about duration in general. What is it good for? Now, duration is good for measuring behaviors that last for a long period of time. It's also useful for behaviors that are targeted for increase or decrease in temporal extent, but not for complete elimination. So, tantrums, for example, might initially be tracked by their duration, but once the duration is reduced to a specific point, frequency may be a better dimension. So instead of timing how long the duration is going for, because at first the duration may be the best choice of measurement because the duration of the tantrum lasts for a very long time. Say this individual cries for a 30-minute period. That's a very long time for somebody to be crying. But eventually you've decreased that behavior to them just crying here and there. Those instances can be then used as count. So if they're only crying for like 30 seconds or 2 minutes, you could say, okay, this child, she cried for 3 times during this session, right? We could also use this as rate, which is great. We could also use it as frequency and rate combined, but duration is just the total time combined. Next, we have A-4, measure latency, aka response latency, temporal locus. So this is part of the measurable dimension of temporal locus. This is a point in time. It is also a continuous measurement, which is a discrete behavior, which means that it is a behavior that eventually ends. So we are talking about discontinuous behaviors anytime you talk about continuous measurement. Latency. Latency is the time from onset of a stimulus to initiation of the response. Another way to think about this is how long it takes for someone to respond to a cue, or a prompt, or a question. Think about when teachers ask you questions in class, and they say, hey Billy, what is 2 plus 4? From the end of that SD 2 plus 4 to when Billy finally says 4 is the response latency. It's the time between the end of that last part of the sentence when the teacher said what is 2 plus 4 to when Billy says the answer. Okay? So another example would be a teacher calls out a student's name. The student orients to the teacher 8 seconds later. The behavior or response occurred 8 seconds after the stimulus. Okay, so during a feeding program, you want to know how long it takes for the student to accept the spoon of food. You're going to put the food to his lips. If he takes it immediately, your response latency is probably less than 1 second. If you're holding it at his lips and then he finally opens it after 6 seconds, that's your latency to the time when he actually took the spoon in his mouth and ate the food. A-05. Many individuals get inter-response time and latency confused. Latency typically occurs at the beginning of a scenario. So when they ask in the scenario at the very end, what was the latency of the behavior occurring? Usually at the beginning of the scenario, it will say the latency of how long it took for a behavior to occur. Whereas measuring inter-response time, also part of temporal locus and continuous measurement system, which is a discontinuous behavior. IRT is the initials for it, is basically the time between the end of one response and the beginning of another same response. So it has to be within the same response class, okay? So you can't just go from hitting to kicking to spitting. Those are totally different behaviors that look totally different. So it has to be the same behavior, and we're looking at the same behavior over an extended period of time within a continuous measurement. But it does eventually end. That's why it's considered a continuous measurement, that is a discontinuous behavior, because it eventually does end. So for example, a child hits his head or forehead with an open hand with only 2 to 10 seconds in between another same response. So picture a child sitting at the desk with you. He hits his head. Okay, you can also count frequency in this. You check off 1 time he hits his head. 30 seconds later, he hits his head again. 30 seconds later, he hits his head again. So that behavior occurred 3 times, but what was the IRT between him hitting his head? So between those instances of him hitting his head was 30 seconds each time. Now with IRT, you can also get an average IRT that is questioned to you. So average IRT is basically you're going to combine that 30 seconds with a 30 seconds that occurred, and you're going to combine it to equal 60 seconds. You're going to divide that by 2, which equals obviously 30 seconds, and that's the average IRT of the amount of time that occurs between each instance of the behavior of head hitting. IRT also is typically paired with DRL, which is differential reinforcement of low rates of behavior, which we will eventually get to later on. A-6, measure percent of occurrence. So we kind of spoke about this with A-1 frequency because you're counting. Measure percent of occurrence is like counting. It's like frequency. It has minimal observation intervals or response opportunities that are needed though. So you need at least 30 response opportunities for you to be able to get an accurate percent of occurrence of the behavior occurring. So going back to the teacher grading the papers, think about this. The teacher grades a paper and you get a certain percentage, you get a certain grade. Say that you had 10 math facts that you had to do and you got 5 right. That is 5 correct out of 10. That would be 50% correct. So that's the percent of occurrence that you got correct. If we were to do it the other way around and say how many the individual got wrong, you could say they got 5 wrong out of 10 questions. That would be 50% incorrect. That is the percentage of occurrence that they got incorrect. Now we could also say if a student answered correctly 39 of 50 problems, so we can get higher. Accuracy percentage can be calculated by dividing the number, so we're dividing, of correct answers by the total number of test items and multiplying that product by 100, okay? So we're always multiplying by 100 because we want to know what our final percentage is. We're not going to leave it in decimal form. The percent of occurrence is a ratio of a measure divided by the total of the same measure. Most often it is indicative of the frequency of occurrence, so we spoke about A-1 frequency, which is count, over the total frequency, such as the number of trials with correct responses divided by the total number of trials. This can be used with other measures such as duration or IRT. Measuring percent of occurrence is a derivative behavior, or a derivative measure, I should say. It's a derivative measure, meaning it's not a part of continuous measurement. Okay, so this is one of two derivative measures. Another example of percent of occurrence. You decide to record on-task behavior. For recording purposes, you separate the 20-minute class period into 40 30-second time intervals. When you are finished recording, you find that the client was on task in 30 of the intervals, and using percent of occurrence, you would say that the client was on task 75% of the time. 30 on-task intervals divided by 40 total intervals equals 0.75 multiplied by 100 equals 75%. You should only use percent of occurrence when the total number of measured intervals are 30 or more. Because if you don't use that, it's not going to give you accurate readings for your measurement system. Think about this. You have 5 total intervals, and the behavior observed in all intervals was 100%, right? 3 fewer behaviors observed was 40%. 5 fewer behaviors observed was 0%. Not as accurate as we're hoping. If you had 30 total intervals and the behaviors observed in all intervals was 100%, 3 fewer behaviors observed would be 93%, and 5 fewer behaviors observed would be 83%. So it's a little more accurate because it gives you an actual percentage of how much you are actually seeing versus going from 40% to 0%. That is a very big amount to look at because of the fact you're going from 0 to 40. Whereas the other example is 83 to 93%. That's more accurate. Moving on to our next A-0, measure trials to criterion. This is also a discrete measurement. So trials to criterion basically is the total number of response opportunities or trials required in order to achieve a set level of performance. That is, how many times, we're looking at count again, did a client attempt a behavior before achieving it? The expectation needs to be well defined beforehand. For example, both the behavior that must be exhibited during the trials and what constitutes completion. Example, how many times did it take for your daughter to tie their shoes correctly? How many times did it take for a child to correctly form the letter M on the paper? You know, those worksheets that sometimes you're given by the OT therapist in your building that you might have, or the child works with in the home. They give these papers out, and we start with the full dots to tracing the letter M, and then we start discontinuing the full dots, and we start to just put a little amount of dots, and then eventually they're writing the M by themselves. How many trials did that take the individual to actually be able to write the M without the dotted lines? So another example of trials to criterion would be teaching a child the concept of the color red. You're presenting the child with items that are red and not red and providing differential reinforcement for correct responses. Trials to criterion data is collected on the number of red and not red exemplar, which is required before the child is to specify a certain level of performance within a discrimination. For example, it took Tammy 20 trials to learn what is red versus not red, or it took 11 trials which were required for mastery of shoe tying. How many trials did it take until mastery of the criterion? So trials to mastery is the AKA to trials to criterion. A-O, everyone's favorite, IOA, Inter-Observer Agreement, which is also known as believability because we want believability when we are taking IOA. So IOA is the extent to which two observers agree, which means agreement increases believability or measurement quality, while not directly increasing accuracy, validity, or reliability, which we will get to, so don't worry about those three words right now. The target for IOA is always going to be 80% agreement, with collection occurring in 20 to 30% of measurement occasions across all conditions. IOA is the most widely used assessment of measurement quality in ABA. It really is agreeing on whether a behavior occurred or didn't occur. There are multiple ways to measure IOA. There's total count, there's total duration, there's mean count, there's mean duration, there's exact count, there's interval by interval, there's trial by trial, there's scored interval, and there's unscored interval. That seems like a lot, but it's honestly not a lot because there's only 4 mathematical equations that you realistically need to remember because many of them are the same. It's just changing whether you're counting in numbers or if you're counting in seconds, or like tallies to seconds, if you want to think of it that way. So here we are showing methods for calculating IOA. We have 4 event recording IOAs: total count, mean count, exact count, and trial by trial. Then you have 2 timing duration IOAs: total duration and mean duration. Then you have 3 time sampling interval recording IOAs: interval by interval, scored interval, and unscored interval. You don't necessarily need to know what they're under per se, you just need to know how to calculate them and what they're all about. So first I'm showing you total count, IOA, and total duration. Why do I have these paired together? It's because they're identical. The only difference here is one you use tallies, one you use seconds. And you can see that when you look at the images. The image to the left under total count, you don't see anything next to the numbers 2, 0, 4, 2, 1, 3, 3, 2. If you look to the right, you see 2 seconds, 0 seconds, 4 seconds, 2 seconds, 8 seconds in the intervals for what the observers saw. Okay, so realistically the only difference here is whether it's tallies or seconds or minutes or hours. So to calculate total count, which is the simplest and crudest IOA out there, remember those keywords, simplest and crudest. Why is it the simplest? Well, think about this. You are literally just adding observer 1's intervals 2 plus 0 plus 4 plus 2, which equals 8, and then observer 2's intervals, which is 1 plus 3 plus 3 plus 2, which is also 9. So you're doing 8 divided by 9, right? So you're taking the smallest number of intervals over the largest number of intervals. 8 divided by 9 equals 0.88 multiplied by 100 equals 88%. Okay? That's why it's considered the simplest and crudest. Crudest because it's not always going to be accurate. I mean, one of the observers could see 0 behaviors occurring, and then the other observer could see like 4 or 5 behaviors occurring. And if you get 88%, I mean, that's over 80%, right? So it's telling you that it's pretty accurate, but is it believable? Okay. Then we have mean count and mean duration. Again, same calculations, that's why I paired them together. Only difference is the tallies versus the seconds. Here we have mean duration to the left and mean count to the right. For calculating mean, it is the more intense type of calculation, but once you get the hang of it in practice, it's pretty simple. So for mean count, we're going to take interval 1 for observer 1, so Janet, under interval 1 says 2. For Carl, it says 1, so we're going to take 1 divided by 2, which is 0.5, and then we're going to take under interval 2, 0 divided by 3, which is 0, and then interval 3, we're going to take 3 divided by 4, which is 0.75, and then we're going to, under interval 4, 2 divided by 2, which is 1. So you see how we just basically divided out each interval by observer? Now we're going to take those decimals and we're going to add them together. We're going to add them together, which equals 2.25. We're still in decimal form. Remember, we want to get to percentage. Now we're going to get that 2.25 that we added together from those decimals, and we're going to divide that number by the total number of intervals that you have. So we have 4 intervals. So 2.25 divided by 4 equals 56%, or 0.56, I apologize, 0.56 because we're still in decimal, multiplied by 100, which equals 56%. So it's not showing that we reached the 80% criteria, which we want because that's more believable. So it means we have to go back and maybe track IOA again, check in with the other observer, maybe there's something you missed. Obviously, we're not going to take data with the other observer because that's how you get reactivity, that's how you get observer drift, all these different things occur. So we're going to go and discuss it with the other observer about what they saw, and we're going to figure out why it's at 56% instead of 80. Okay? Mean duration is more stringent, so more stringent. Okay? Then we have exact count, and exact count, of course, is by itself. So exact count IOA is the most strictest or most stringent. Why? Because we're going to circle the intervals where both observers agree that a behavior occurred. So if you look at the table below, I've circled where the observers agreed that the same number of behaviors occurred. Then you're going to take those numbers and you're going to divide them by the total intervals. So we're going to take interval 2, 4, and 5, which is 3 intervals, divide them by the total number of intervals, which is 5, and we're going to multiply that by 100 to get the percentage. So here you can see that they only were able to get 60%. Again, is it believable? If it's not over 80, then we have to question our math. We have to question what went on in the environment. Were there confounding variables? Were there extraneous variables? There's a reason why it was so low. Trial by trial. Did they agree? All right, another one by itself. So you're going to circle the intervals where both observers agreed with a yes or no, okay? So most of the time, trial by trial, you're going to see 0 or 1. Okay? You're going to divide those intervals where they agreed that they either saw a behavior or didn't see a behavior, and then you're going to divide that by the total number of intervals, multiply by 100 to get a percentage. So right here we have interval 2, 3, 4, 5, where they both saw the same amount of behaviors, or they saw the same behavior occur, or they did not see the same behavior occur. And then you're going to take 4 divided by 5, which is 0.80 multiplied by 100 to equal 80%. All right, sometimes you'll see trial by trial, like point by point, also as an AKA. Then we have interval by interval, very similar to trial by trial. I just separated them on 2 different pages because there is a wider display down below for intervals. So here again, it's going to say no or yes, usually with interval by interval. It can also say X and O. With this one, you're doing the exact same thing as trial by trial. Again, trial by trial, I should mention, trial by trial is used with discrete trial training. That's why it's considered trial by trial, because you are saying whether or not during that trial they were able to correctly respond or not correctly respond. So remember, trial by trial is paired with a discrete trial training. Then we have interval by interval, which is different. And this one, you are going to see yes or no on whether they saw a behavior or did not. You're going to circle where they agreed, divide that number by the total number of intervals, and then you're going to get a decimal, multiply it by 100, which equals the percentage. Now this can subject to random or accidental agreement between observers, just because it can overestimate the behavior that occurs at very high rates or very low rates. Moving forward to scored interval IOA. Now many get scored and unscored confused, but I will make sure I explain it in the simplest way possible. Scored. Look at the first word here, scored. It starts with a S. It's because you saw a behavior. Scored is saw. Scored interval IOA, you saw a behavior. That's the only time you're going to record that a behavior occurred. You're not going to record a behavior didn't occur. You're going to agree on that you both saw a behavior. So you're going to record whether you saw a behavior. You're going to circle the intervals where both agreed and divide the intervals by at least one observer saw a behavior. So as you can see here, interval 1, at least one saw a behavior. So we're going to circle it. Interval 2, neither of them saw a behavior, so we're going to leave it alone. Interval 3, both of them saw a behavior, so we're going to circle it. Interval 4, neither of them did. And interval 5, at least one did. So in this, you're going to take out interval 2 and 4. They don't exist. You're going to take interval 3, where they both agreed. That's one interval where they both agreed that they saw a behavior. And then you're going to take all of the intervals that at least one of them saw a behavior. So there's 3 intervals. And you're going to take 1 divided by 3, because we don't care about the other intervals that have 0, because they didn't see a behavior during those. So 1 divided by 3 is 0.33 multiplied by 100 equals 33%. With scored intervals, you're going to use this for low rate behaviors. So 33% is actually a good percentage, because that means the behavior is low rate. Okay, so you're going to look for around 30 or less. So 33 is a little higher than 30, but it's not by much. So we're going to look for 30 or less. So recommend for behaviors that occur at frequencies or approximately 30% of intervals or fewer to avoid overinflated and possibly misleading IOA measures. Unscored, it's the complete opposite of scored. Now you're going to look for no behavior. So unscored, no behavior. You're going to record whether each observer did not see a behavior. Okay? So you're going to look at the intervals and you're going to circle the intervals where they did not see a behavior. Okay, so interval 1, 2, 4, and 5, they did not see a behavior. At least one of them did not. Now, which intervals did they agree that they both did not see a behavior? Look at interval 2 and look at interval 4. They both did not see behavior. So that's 2 intervals where they both did not see a behavior. And then a total of 4 intervals where at least one did not see a behavior. So 2 divided by 4 is 0.5, multiplied by 100 equals 50%. And minimum for effects of chance of agreement for interval data on behaviors that occur at very high rates or very low rates. Unscored is used for high rate behaviors. A-09. Now we're getting a little more in depth. This is evaluate the accuracy and reliability of measurement procedures. It doesn't say it in the title, but we usually pair validity with accuracy and reliability as part of our measurement procedures. In Cooper, you will find that it is paired together. Our task list just chooses to use accuracy and reliability. So accuracy. Accuracy, this means that what you've measured to be true is the same or close to what is actually true. For example, if you go to the doctor's and the scale says 120 pounds and you weigh 120 pounds, but you go home and you weigh yourself and it says that you weigh 115 pounds, which scale do you think is not accurate? Think of true value for accuracy. The scale at home is most likely not calibrated correctly because you bought it from, say, Walmart and you didn't calibrate it. So that scale is not going to be accurate. If you go to the doctor's, they most likely have an accurate scale because they've calibrated it. So that's going to be more accurate. When you are measuring something, you're going to want to measure it to its true value, the item that is more accurate. Okay? For me, for instance, when I go on walks or at the end of the day after just walking around in general, I compare what my phone says to my watch to see if they are accurate, if they read the same measurement system for how many steps I took. So I could say that my phone is probably least accurate because I don't always wear my phone in my pocket, whereas my watch is probably more accurate because it's on my arm as soon as I get up in the morning to as soon as I go to bed. Okay, so you want to compare to the most accurate true value measurement. Then we have reliability. Reliability is pretty simple. It's just the repeated measurement of an event that yields the same or similar results. If you go to the doctor at 5 a.m. and they weigh you 120 pounds, and then you need to come back for more test results at noon and you're still 120 pounds when they measure you again because they like to weigh you every single time you come back to the doctor's. And then you go to the doctor's again for a 4 p.m. appointment because you need more work done and you weigh 120 pounds, that means that scale is reliable. It's consistent. You were able to measure the same weight every single time, so it is reliable. So now we have accurate scale because it's accurate every single time because it's been calibrated to its true value, and it's reliable. That's really good that you have both of those. Okay, so another example would be accurately measuring how many times you went for a walk today. So my watch calculates how many times I walked, right? Or how many steps I took. That's accurate. How do I know it's reliable though? I know it's reliable because I make sure that every time I go the same distance, it's the same amount of steps. Okay, so if I were to walk to the end of the street and back, that's usually about 120 steps. And then the next day I do the same pace. It's about 118, sometimes 121. Still reliable, right? Because you're still able to get close to the same results that you have done day after day after day walking. There are, of course, some threats when it comes to reliability and accuracy. They hold the same threats. Common threat is obviously human error, poorly designed measurement systems. You want to make sure that you're always choosing the right measurement system to use. You're not going to use a tape measure to measure how many steps you took. That wouldn't be accurate or reliable, right? And we'll get into validity to show you how that can also occur for poorly designed measurement systems. Also, inadequate observer training. If you don't train your observer or your staff well, you're not going to get accurate data or reliable data. As well as expectations of what data should look like, observer drift, measurement bias, observer reactivity, all three of these can occur. We'll get further into the definitions as we go through the task list, but these are just a few of the threats to reliability and accuracy. So if I said Dana weighs 130 pounds at home and she goes to the doctor's and she weighs 140 pounds, so while the scale at home was reliable, it wasn't accurate. It was close to the 140 pounds, right? It's similar measurement, similar weight, but it wasn't accurate because it didn't yield 140 each time. Then we have validity. Now validity, although validity isn't specifically mentioned in the task list as I mentioned, it is important to distinguish it from accuracy and reliability. Okay, so measuring validity is more or less just saying, are you measuring what you intended to measure? So if I were to take a cup of coffee and put it on the counter, and I wanted to tell you to do this, for example, take the thermometer and tell me what the temperature of the coffee is after it was poured. But instead of taking the thermometer, you take a ruler and you measure how tall or how much is in the cup. That's not going to be accurate, right? It's not going to be reliable. And you're also using the wrong measurement system, okay? So you're getting the wrong data from this. It's not valid. So validity, it's the extent to which data obtained from measurement are directly relevant to the target behavior of interest and to the reason for measuring it. Directly measuring socially significant target behaviors. So make sure you're measuring the right behavior. If I wrote on a step sheet that we're measuring how many times an individual hits themselves during the session with you, and you decide to take measurement on how many times they smack themselves, hitting and smacking can be defined very differently. So you want to make sure that you're measuring accurately, reliably, and you're measuring the right thing, okay? So it doesn't just have to be what system of dimension you're measuring, so you can be measuring frequency, duration, latency, IRT. You want to make sure that you're measuring the correct one for that behavior. But if you're not measuring the right behavior, observer drift, all those things can occur, then you're not going to have valid calculations, right? So there are also threats to validity. We have indirect measurement, measuring the wrong dimension, which I said, frequency, duration, latency, IRT rate, and measurement artifact, which we'll get into further along as well. It's just basically over-exaggerating. So another example would be measuring frequency when you should have measured duration. For example, when I spoke about tantruming, we had first spoke about how tantruming could be best measured with duration, but once it has reached a certain level in the behavior and decreased significantly enough, you can measure it with frequency. Knowing the difference between frequency and duration is extremely important, and when to use duration versus frequency for tantruming behavior. A-10, design, plot, and interpret data using equal interval graphs. So we have 4 different equal interval graphs. We have line graphs, which are the most commonly used in our field. We have bar graphs, we have cumulative records, and scatter plots. So line graph. A line graph's AKA is frequency polygon. This is the most commonly used graphic format for displaying data. And I would think if you work in the environment of applied behavior analysis, you've probably used a line graph several times. A line graph is based on the Cartesian plane, which is just where the x and y axis meet. The horizontal axis is the x-axis, which is at the bottom of your graph, and that's also called the abscissa. No one can say that word right, so don't try to say that word right. I mean, great for you if you can, kudos. But the x-axis, that is where you're going to put your intervention. A lot of people get this confused. So the bottom of your graph is usually your IV, your independent variable. The vertical axis, which is your y-axis, the ordinate, which is on the left side of the graph, that is where you're going to put what you're measuring. So frequency of head hits, duration of tantruming, you're going to put those on the left side. It's the behavior, it's the dependent variable. Other parts of a line graph are condition change lines, which are between your your intervention and your baseline. So if you have an ABA-B graph, you're going to have condition change lines in between to separate them. Then you have condition labels. The A and the B are going to be labeled. You're going to have baseline, then you're going to have your intervention, then you're going to have baseline, then you're going to have your intervention. You want those labeled so that we know which ones we are looking at and whether the intervention actually worked. Data points. Easier said than done. It's literally you put dots on the graph where the behavior occurred. So if they hit their head 24 times in 14 minutes, you're going to put that they hit their head 24 times on the graph. And then you're going to put the next day that they hit their head 16 times on the graph. So those are going to be data points of where they hit their head and how many times. The data path is going to be those lines connecting. So you're going to see with the data path that it usually is part of the trend, which we'll get into obviously coming up. It's going to show you an increase or decrease with those paths to see how the intervention is correlating to your dependent variable and whether it's working or not. And then the figure caption, you're going to need that at the very bottom of the graph to tell individuals what the graph is displaying. Okay, it's just basically a general description of what the graph is showing in 2 to 3 sentences. The line graph is typically used to compare the level, trend, and variability, which we will discuss. This is what a typical line graph can look like. Here you see baseline has been taken. On the left side where the black dots are, those are your data points. The data path is connecting those data points. Okay? The x-axis is on the bottom, the horizontal axis, your abscus. That is showing you're taking your intervention or your independent variable as days you're tracking this behavior. You're tracking per day, okay? And then the behavior is on your vertical axis, your y-axis, which is to the left. That is tracking your frequency of disruptions. And the intervention here, which is your label, praise, is on the right side in the red dots. Bar graph, aka histogram. It is a simple and versatile graph format for summarizing behavioral data. Keep that keyword in your head, summarizing. It shares most of the line graph's features except that it does not have distinct data points representing successive response measures through time. Okay? It's based on the Cartesian plane, obviously because it connects, and shares most of the line graph's features with one primary difference. It does not have a distinct data point representing successive response measures through time again, okay? It's good for a quick comparison, that keyword comparison, of performance across participants and or conditions. A lot of time we can use bar graphs for preference assessments and or reinforcer assessments to compare items. It is good for a visual summary, but it's not great for a visual analysis. It's because of the fact that it doesn't really show variability or a trend. It definitely shows level, but it's missing variability and trend, so it's not going to give us an accurate reading or look at how the behavior is. So we wouldn't use this with like tantruming behaviors or property destruction or SIB or aggression, because it's not going to compare anything to an intervention, okay? So yes, we're comparing things, but we're not comparing them to interventions. We're comparing things such as preference assessments. Did the individual choose the gummy bears over the Skittles more? You know, those type of things. So this is what a typical bar graph looks like. And here you can see at the bottom on the horizontal axis the labels for what each item was presented and how many times on the left side, the vertical axis, that they chose these items. Okay? At the top, make sure you read the entire graph because I didn't just this time. Incidents by activity. So obviously this was a behavior that occurred when they were using or were located in these destinations or these specific settings, okay? So during snack time, it looks like he had a low level of behaviors, but during the whole group time, it was a high level of incidents that occurred. In this type of graph, it shows that behaviors did occur certain amounts of time. So you can use it for typical like behaviors that you're not realistically using an intervention for, but it's not a great visual analysis, so we tend to stay away from bar graphs with those type of behaviors. Scatter plot, aka pattern analysis. So this is a graphic display that shows the relative distribution of individual measures in a data set with respect to the variables affected by the y-axis. So data points on a scatter plot are unconnected. Okay, so you're not going to see them connected ever. So as soon as you see that, you're going to know it's a scatter plot. Don't get this confused with a multiple probe design, because on a multiple probe design in baseline, they're typically not connected, but you'll see in the intervention that they become connected. On scatter plots, you're going to see just a whole bunch of dots that look like a bunch of bugs all over the paper on the graph, all over the place, and they're not connected. The data points are used to show how much changes in the value of variable depicted by one axis correlated with changes in the value of a variable represented by the other axis. Okay, so typically we use scatter plots for like time distribution or temporal distribution of when the behavior occurred. So on the next page, I believe, there we go. On the left side, you can hand the left form to a parent. If you don't have time to observe different times of the day to see when the behavior most likely occurs. You can also give this to a teacher. It's very simple to mark. So where you see like the full black squares, that means the behavior occurred more than a specific time or amount of times. And then where the X's are, there was a certain amount of times that it occurred, and then where the slashes are, there was a certain amount of times the behavior occurred, and then where there's empty squares, obviously the behavior did not occur. But that's going to give you a temporal location of when the behavior occurred the most, and you're going to want to go in and observe during or around that time frame to see what's going on. You want to see what the antecedents are and the consequences and the behavior. So you want to see all that ABC data at a specific time of day, and you're going to get the best ABC data during a time period when you know the behavior is going to occur based on the data sheet. The graph to the right is what you would graph based on the graph to the left. Yes, they're both considered types of graphs. One's just more simpler to read. And as I said, it looks like a bunch of bugs on paper, little dots. Level, trend, and variability. We have reached the point where these three items can be very confusing, but at the same time, very simple to understand once you do actually understand their definitions. Level. It's just the value on the vertical axis around which a series of data measures converge. In other words, those data points that we spoke about, you're going to add those up. You're going to add up those data points. So if they got 3, 4, 2, and 1, that's 7 plus 2 is 9 plus 1 is 10. That's 4 data points, right? So you're going to take 10 divided by 4. You're going to get a certain decimal multiplied by 100 to get a percentage. That's where you're going to get your level line. So say, I don't know what it is right off the top of my head, you're going to say get 6, okay? You're going to put your level line across from 6 on the actual graph, a line graph, okay? And that's where your level is going to be. Okay, then you have your trend, and this is the overall direction taken by the data path. Is it increasing? Is it decreasing? Is it zero trend where nothing's going on? Is it gradual? Is it steep? Is it ascending? Is it descending? Okay, so when you look at a graph and you see data points on the graph and data paths and data points on the graph, which direction are they headed in? Then you have variability. This is the extent to which the data points bounce around on the graph. You can have high and low variability. High variability will look like something where the data points are starting off at the very bottom and then they go all the way to the top, and then they go all the way to the bottom, and then all the way to the top of the graph. That's going to be high variability because they're bouncing around way too much. Low variability would be like, okay, it goes from data point 1 to data point 2, data point 1 to data point 2. That's very low and minimal. So there's not much variability. Going back to the graph that I just spoke about a little while ago with line graphs, we can discuss level, trend, and variability here. So if we look at the baseline, so we see baseline, we see the black data points, right? So we're going to look at those black data points. We're just going to estimate here and not really take accurate data like we should, but this is just for an example. So the first data point that we see over day 1 is across from 7. So we're going to take 7, okay? That's data point 1. Day 2, data point 2 is across from 6, so we're going to add 6. Day 3, data point 3 is across from 7. So we have 7, 6, 7. That equals 20. Now we're going to divide it by 3. So the level, average level, is 6.6. So we're just going to put it between 6 and 7, the line, and we're going to draw across. And that will be your average level of baseline. We could do the same to praise. If you want more easily done, if you just need a quick comparison of level, you could take from the first data point on day 4, draw a straight line all the way across to day 13's data point, and that would be your level. Okay. Trend. This one doesn't really have an accurate trend on it, so we would have to say 0 trend because there's really no trend on the praise area, right? The intervention. If it had a trend, it would have more than one data point, whereas we only have one data point. We don't know realistically where it's headed, okay? So if it had another data point after day 13 on day 14 and it went to frequency of disruptions was 6, okay, so we see an increasing trend, right? But if after day 13 it dropped down to frequency of disruptions 2 on day 14, we'd have a decreasing trend. But because there is no data point after day 13 and it's very little there, we don't know which direction it's going to go in, we're going to say this has 0 trend. Okay. Variability. This has mid-level variability. What does that mean? It means just in the middle of the graph, between 0 and 8 for disruptions. Okay, so it's mid-level. Is it high variability? Is it low? Well, we start off kind of high in variability, but then we go sort of low in variability, so we're not going to say this is stable for sure, but we're going to say it's variable. Okay? Variable to the point where maybe there's no variability here. A-11. Design, plot, and interpret data using a cumulative record to display data. So we spoke about in our equal intervals, a cumulative record is part of equal interval graphs. It is separated on our task list because there's more in-depth information within a cumulative record that makes it different from the other graphs. So a cumulative record of behaviors is just that. It's a record of all the behaviors that have occurred over time. Okay? So in that instance, we're going to say, okay, it's the total number of behaviors recorded over time. What does that mean? Cumulative records never decrease. This record was actually developed by Skinner many years ago, where he developed the cumulative recorder, which would track the data on a cumulative record, and the data would always increase. It would always be ascending. It never decreases, okay? On a cumulative record, a flat line would indicate a period of no performance of the behavior, okay? And then a steep slope indicates more instances of a target behavior. So the steeper the slope, the higher the response rate. Make sure you remember that, okay? This is what a cumulative record looks like. This is just a typical one out there. There are variations of a cumulative record as well, where you can also have condition change lines in between based on your cumulative record that you want to take data on. As you see, the data is consistently increasing. You can use a cumulative record for self-management behaviors. You can use it for how much money you made today, how much money you made tomorrow, a savings account. You put money in your savings account, you put 5 today, and then next week you put 10, and then next week you put 15. So you're saving over time. So you're using it for increasing behaviors of performance of the behavior. You never want it to decrease on this. You would never use it for a behavior that you want to decrease. Right where you see the triangle, this would be your local response rate. Local response rate is just between a set of data points on your cumulative record. It's smaller than the overall response rate, which would be all of your data points. And you're going to take those data points and you're going to divide the total number of data points by the number. So you're going to say this one, a little harder to read. It's on the 15 for the first data point, and on the 20 for the last. So you're going to take like 15 divided by 20, which we're going to calculate so you can have it accurate, which is 0.75. So your local response rate would be 0.75. Obviously, you can multiply it by 100 to get percentage, but we typically leave these in decimal form. Then, if you were going to get your overall response rate, you typically don't start at the first data point because realistically, what are you saving above? Okay, yeah, we typically start at 0, but we're going to go to the second data point and we're going to estimate the second data point at 4, say, okay? So we're going to take 4 and now we're going to look at the top, which is 20, okay? So we're going to do 4 divided by 20 and your overall response rate would be 0.2. A-12. Design and implement continuous measurement procedures, also known as event recording. Remember in the beginning, I was speaking about continuous measurement procedures. Rate, frequency, duration, latency, IRT, all of those are continuous measurements, which are also discontinuous behaviors. Yes, it's going to get confusing in a second. So, continuous measurement procedures involve all instances of a response class being detected. Keyword, all instances. This includes narrative event recording, ABC event recording, and any direct observation or video recording. So it's useful for behaviors that are free operant, have a discrete beginning and ending, require minimal displacement of the organism in time and space, can be emitted at any time, do not require much time for completion. So those are what they would be useful for. However, it's not great for behaviors that occur at high rates, are measured through discrete trials, because in those you only get like one chance or one response. Not good for behaviors that occur for extended periods of time, and not good for behaviors that are opportunity-based, like discrete trials. So again, parts of the continuous measurement procedure: count, frequency, duration, latency, and IRT. You're measuring all instances of the behavior. They're all going to be detected. A-13, design and implement discontinuous measurement procedures. So we have partial, whole, and momentary. Those are discontinuous measurement procedures. They're also known as continuous behaviors, okay? So in discontinuous measurement, some instances of the behavior may not be detected. That is, you aren't observing every occurrence of the behavior. Instead, you are estimating the occurrence of behavior using one of the 3 methods I mentioned: partial, whole, or momentary time sampling. It is a direct measurement because when behavior is actually observed, it is the same behavior that is the focus of the data collection. Okay, so make sure that you're calculating and observing the same behavior. This is contrast with indirect measures, which are interviews or questionnaires. We will get into this, don't worry. All right, so first up we have partial interval. Partial interval is a discontinuous measurement. It is direct time sampling procedure where a behavior is recorded as occurring if it occurs at least once. So if it occurred 16 times, you're only recording it happened once. And that's per interval. It may slightly overestimate occurrence of the target behavior, and findings are going to be reported as percentage or rate. Okay, the reason it overestimates is because of the fact that you're recording as if the behavior only occurred once and not like 20 times. Then you have whole interval, and this is another discontinuous measurement. This is the direct time sampling method. It's a behavior is recorded as occurring as if it occurred observed throughout the entire interval. So you can't realistically use it for behaviors that occur like once. Okay, so if a behavior is just going to occur like once during an interval, probably stick to partial. But if this is a behavior like tantruming and it occurs at relatively high rates and it occurs for long durations, you're probably going to use whole to say that it happened the entire time. However, it may underestimate occurrence of target behavior. Why? Because if the behavior happened longer than that interval, we're not going to know. So it's going to underestimate how long the behavior actually occurred. Then you have momentary time sampling, and this is another discontinuous measurement. It's it's direct data sampling procedure in which at the end of a predetermined interval, a recording is made if the behavior is occurring at that moment. So if you're, say, at your desk with an individual and you have a timer of 5 minutes, you put that timer on for 5 minutes. The timer goes off at 5 minutes. You look over at your student. Is the behavior of, say, nose picking happening? If it is, mark a check. If it's not, mark an X. Okay? This tends to over and underestimate the behavior occurring. Because what if he's nose picking the entire 5 minutes? Or he nose picked more than once during those 5 minutes, So it could overestimate and underestimate the occurrence of the behavior. So for momentary time sampling, again, it's going to be reported as percentage or rate. Another example would be, let's say that a client blurts out movie quotations during class, such as, "You can't handle the truth," or "I'll be back." You want to use a discontinuous measurement to record the behavior's occurrence. One behavior occurrence lasts about 3 to 10 seconds, so we're going to look at the measurement tools separately using 15-second interval recording. So why are we choosing more amount of time than what it actually lasts for? So the behavior here occurs for 3 to 10 seconds, we said, right? But we're choosing an interval that's 15 seconds. Well, what happens if that behavior lasts for 15 seconds? What if we miss it? So we're going to make the interval a little bit longer and see if when we look up in momentary time sampling that the behavior is still occurring. Okay. Going back to partial interval, you would record the behavior as having occurred when the quotations happened during any part of a 15-second interval. You would probably record most behaviors, but would miss any time that a behavior occurred more than once during the interval. You would record a behavior twice if it started at the end of one interval and spilled over into the next interval. This is how a partial interval tends to overestimate occurrence, because it has the spillover effects. Whole interval, you'd record the quotation if the behavior happened for an entire 15-second interval. If the behavior occurred for 14 of the 15 seconds, you would not record the behavior as occurring. So that means you're going to underestimate the behavior actually occurring during that interval if you're not recording it because it missed it by 1 second. And then momentary time sampling, you're recording quotations if they are occurring in the last moment of the 15-second interval. If the behavior did not occur at that time, it's not recorded. And like I said, it can over and underestimate. And it's probably more likely to underestimate the occurrence. So the takeaway from all of this is all of these discontinuous measurements may produce artifacts, so over-exaggeration, byproducts of being inaccurate in your measurement. Discrete measurements, in contrast, capture all of the instances of the behavior. So this is just a great visual to use, a breakdown of partial, whole, and momentary. If you're watching the recording, you're totally welcome to pause, screenshot it, or pause and write it all out on flashcards, which I highly recommend. And lastly, A-14, design and implement choice measures. A lot of people don't understand that choice measures, I know from when I began studying over a year ago, choice measures, I was like, what's a choice measure? Because I would look in other areas of Cooper and Pass the Big, and it really didn't explain what choice measures are. Well, choice measures basically are stimulus preference assessments and reinforcer assessments. It's where they're making a choice, right? So in stimulus preference assessments, we have asking the person, free operant observation, and trial-based methods. In reinforcer assessments, we have concurrent, multiple schedule, and progressive ratio. So the first one we're going to talk about is stimulus preference assessment. So a stimulus preference assessment is basically just getting a preference of what the individual may like. It's not saying that they're actually liking this item, not yet at least, is just getting a kind of like a view into their world of what they may like and what you could use as a potential reinforcer. So the first part of a stimulus assessment that you could use is asking about stimulus preference. So you could ask the person open-ended questions about what they like. You could use a choice format, a ranking order. You could ask significant others if the individual is incapable of communicating. You could offer a pre-task choice. Do you want to play with the bouncy ball or do you want to play with the jump rope? Then you have free operant observation. This is observing and recording what activities the target person engages in when she can choose during a period of unrestricted access to numerous activities in the natural environment. You have two forms of free operant observations. You have naturalistic and contrived. Okay? So contrived would be that you set up the classroom before your student gets there and you put out 10 items that you potentially think the student will play with. Then you're going to observe when the student gets to the classroom, them playing with those items. That's contrived because you rearranged the environment. Naturalistic is more, you did nothing to the classroom, nothing to the gymnasium area, nothing to the playground, and you just observe them and watch them to see what they play with. And you can also do this in their home environment because you're not going to contrive their home environment either. So you can definitely use this in their home environment or school environment, areas where it's not going to be contrived. Other parts to the stimulus test preference assessment would be trial-based methods. So stimuli are presented to the learner in a series of trials, and the learner's responses to the stimuli are measured as an index of preference. So we're going to have preferred stimuli that are sometimes labeled as high preference, medium preference, and low preference stimuli based on predetermined criteria. So there are a few different types of trial-based methods. We have single stimulus, where you're just presenting one item at a time, typically used for individuals that can become aggressive when items are taken away. So we're going to, or individuals have a hard time choosing between items, and it takes them a very long time to choose between items. The AKA for stimulus, single stimulus, is successive choice. So like I said, you're just presenting one item at a time. You're going to put your timer on for 30 seconds, see what they do with the item, if they're interested, how long they play with it, what they do to manipulate the item. You're taking notes. Then you're going to switch out after 30 seconds when your timer goes up. The individual is going to hand you back the item and you're going to take out another item. Typically you'll have like 6 items just to give them a variety, and you're going to take notes on each item for 30 seconds and what they do with it. You're going to know from there which one they typically prefer, which you can later use in a reinforcer assessment by ranking them in highest preference to lowest preference. Then you have paired stimuli, which is aka forced choice, and this consists of pairing 2 items together. So you're going to take the bouncy ball and the jump rope and you're going to pair them together, and you're going to show the individual. You're going to put the timer on for 30 seconds again. They're going to choose an item because you're going to say, with a response prompt, choose one. They're going to choose an item. Say they chose the bouncy ball. They're playing with the bouncy ball for 30 seconds. They're bouncing it, throwing it, doing whatever they want with it. And then you're going to say, okay, can I see? And you're going to take away the bouncy ball and the jump rope, and you're going to give them 2 other items. Now you're giving them the teddy bear and the train set. They're rolling the train set back and forth for 30 seconds. They're putting it on the floor. They're putting it on the table. They're pretending it's driving on them. And then after 30 seconds, they're going to give it to you again. Okay, and you're going to keep going through this until you've gone through all of your items. But you're pairing 2 items against each other. This can also give you a hierarchy of which items are more preferred over the other. Then we get to multiple stimuli, which is a variation of stimuli. So we have 2 different types of multiple stimuli. We have multiple stimuli with replacement, and then we have multiple stimuli without replacement. Multiple stimuli with replacement is when you put an array of 6 items on the table, and you say to the individual, choose one, and the individual chooses an item. They manipulate, play with the item, do whatever they want with the item for 30 seconds, and then you ask for the item back. You put the item back into the array, remove all of the other items, put 5 more items there that are different, mix them up of where the located item that they chose was, and say, choose one. This again will give you a hierarchy of which item is preferred over the other, and you're going to go through all 6 items, but you're also going to give them new items along the way based on the item that they chose. So you're always going to keep the item that they chose in the array, but you're also going to give them new items along the way based on the items that they didn't choose. Okay? And then you have multiple stimuli without replacement. Okay? So this is where you put an array of 6 items out on the table, and they take an item, they play with it, manipulate it, they put it down. After the 30-second timer goes off, you take it and you put it behind you, and now they have 5 items. Now they're going to play with the next item they chose. This is also going to give you a hierarchy of what they chose, because of the fact that it's going to give you items that they're playing with for a very long time, or they're not playing with it for a very long time, or they're not interested, or they just have no interest in. You're going to know based on what their preference is during this. Then you're going to use these items that you got your hierarchy of, high preference versus low preference, and you're going to go into reinforcer assessments. So we have 3 different types of reinforcer assessments. We have concurrent, we have multiple, and we have progressive ratio. So concurrent schedule of reinforcer assessment is when you pit 2 items that were possibly preferred during your preference assessment against each other to see which one they are willing to work for. Okay, one's going to obviously be more reinforcing than the other. You could do this in a classroom setting. For instance, to Billy, you say, do you want to work on your science sheet for 5 extra minutes of recess, or do you want to read 5 pages in your reading book for extra playtime in the drama area? So you're pitting 2 extremely high reinforcers against each other, something that they like, that are preferred, and you're pitting them against each other, and they're going to choose which one is more reinforcing for them. Okay, so that, say Billy chose the 5 extra minutes of recess, they're most likely going to do their science worksheet. It kind of increases their behavior of doing worksheets by pitting 2 highly preferred reinforcers against them, but getting them also to do their work. Then you have multiple schedule reinforcer assessment. And this again, you're pitting 2 reinforcers against each other, but not at the same time. So multiple is going to be 2 reinforcers, but separate times. Okay? So this would be, for example, in science class, the teacher reinforces you on an FR3 schedule. Okay? But at recess, you see the science teacher, and she only reinforces you on an FR1 schedule. And each time she reinforces you on those schedules, you get a candy. You're going to know when to participate or when to go up to that teacher more often. And most likely it's going to be more often in class, which is what she prefers and what you need to do, right? You need to get the student to do is to participate more in class. So yeah, you're pitting 2 reinforcers against each other, but they're at separate times, okay? Then you're going to do progressive ratio schedule. Unlikely to do it actually in the real setting, just going to say that, because it is kind of not the greatest thing to use. You're using it to a breaking point. Basically, you're giving them so much reinforcement to a breaking point where they're no longer responding, and that's how you get to knowing what reinforces them. So say you reinforce them on an FR1 schedule, then you reinforce them on an FR3 schedule, then you reinforce them on an FR6 schedule, and then finally you reinforce them on an FR7 schedule, and they no longer are responding to you. Well, you just hit breaking point, okay? So we essentially don't really use this in the field anymore, just because it's not so, I feel like it's not ethically right to go to a breaking point of when they're no longer going to respond to you, because it also could make that reinforcer no longer valuable to that individual, right? But in general, for test purposes, progressive ratio is breaking point. How far are they willing to work until reinforcement no longer works? So were they willing to work up to an FR6 schedule or an FR3 schedule? How much reinforcement does it take for this individual to consistently work? All right, so if you have any questions, please reach out to me. I'm always available on our group page. You can private message me. You can leave comments or questions underneath the comment area on YouTube. And I wish you best of luck in your studying.